Right, good morning, everyone. I hope my screen is visible. Okay, let us start, please. Can I get a confirmation? This is okay? We start?
Yes, sir.
Okay, fine. All right, so we are in the 12th lecture of MCA. We're doing memory systems. We just do a small revision, and I want to just talk a bit more on EEPROM and flash and on cache. Okay, I've put a few more photographs just for you to visually understand this also. So let us have a small revision of this memory systems. This is going to be a part of your IA exams. Okay, so everything we teach till over here till this lecture is going to be a part of your IA exams. All right, so we know what is a memory. Memory means anything where we store data. We saw all this yesterday. We saw the units of memory. Then we saw that the basic bifurcation of memory is into two types, that is primary memory and secondary memory. So primary memory means the memory that we are seeing in our inside our CPU or inside our motherboard. All these things are our primary memory. So our RAM and ROM, okay, so RAM and ROM is a part of this primary memory. When I talk of secondary memory, we talk of our hard disk, our CD-ROMs, our USB flash drives. All these are external devices, right? External secondary devices that we use to store our data. Right. So primary memory is basically all the memory that is there as part of our motherboard, or it is called as our main memory or our internal memory. Fine. All this memory are located somewhere near the CPU or inside the CPU. Fine. So if you talk of a laptop, the CPU is present along with the RAM, and that is a part of the primary memory. Fine. Okay. So when I talk of primary memory, we have two parts. We have RAM and the ROM. All right. So these are the RAM slots we normally see. It's called as random access memory. Okay, the one thing to remember that this is a volatile memory. Okay, so whatever data we put inside this thing, it will go away when the system is switched off. Okay, so when you switch off your laptop, all data that is there inside this RAM is gone away. Why do we use RAM for? What is that one thing? Why do we use RAM for? Yesterday we talked about that one word. Okay, what part of your data is stored over here in the RAM? Okay, all your variables. Okay, we have seen yesterday all the variables are stored inside the RAM. Right, so whenever you are having a data variable and you want to change the variable, that variable data is stored inside your RAM, and once your system is switched off, your RAM gets refreshed and it loses all its data. Fine, so it's a volatile memory. Okay, so RAM is called as a volatile memory. And so RAM can you have two kinds of RAMs. Okay, one is called as static RAM and one is called as dynamic RAM. Right, so I put a few photographs of how does a static RAM look like. You can see on the right hand side, it's a static RAM used from the Nintendo Entertainment System. It's an old thing. Okay, it's old. You can say it's a through hole component, so it's a very old device. So it is a 2K into 8 bits. Okay, so it is a 2 kilobyte SRAM. Okay, so 2 kilobyte SRAM from the old systems. Okay, I got it from Wikipedia. You can see on top, you can see there is an SRAM from a company called as ISSI. So it's a breakout board of the SRAM. Okay, so if you want to for example, if you want to add an extra SRAM slot, SRAM to your MCU system or your processor systems, you are going to use an external breakout board like this or an external SRAM like this to interface your MCU with your SRAM. Okay. So in case you find that, okay, my SRAM is not sufficient in my system or my variables are overflowing, what you will use a static RAM like this. Okay, this is an external SRAM piece. So this is SRAM. Okay, what is the difference between SRAM and DRAM? Okay, so next is DRAM. In SRAM, the data has to be refreshed, does not need to be refreshed periodically. Right? So SRAM is very costly. Okay, SRAM is very, very costly when you compare with DRAM. Okay, so but the processing power speed of SRAM is very, very fast. So when you compare SRAM and DRAM in terms of cost, your SRAM is very costly when compared to DRAM. But when you compare your speed, when you compare your speed is also very fast when you with respect to RAM slots. Okay, DRAM. Right? So what is the benefit over here for DRAM? DRAM is cheaper. Okay, so DRAM is cheaper than SRAM, but speed wise you will find that SRAM is very fast than DRAM. So these SRAMs and all are usually in terms of kilobytes or maximum megabytes and all. And we find DRAM to be parts in terms of gigabytes. Okay. This is the example of SRAM which you see on the right hand side of the slide. And then we have dynamic RAM, DRAM. Okay, so these are the dynamic RAM that we normally see. These are the RAM slots, right? So if you open up your laptop or you open up your PC, you will find these RAM slots. So this is DDR3, there is DDR4. Okay, so this is dynamic data rate 4, dynamic data rate 3. These are different kinds of RAM slots. These RAM slots are usually in terms of gigabytes. Okay, so 2 GB or 3 or 4 GB or 8 GB. Okay, in that form. And these need to be refreshed periodically, and it is slower than SRAM. Okay, it is slower than SRAM, but it is cheaper. Okay, very much cheaper than SRAM, and you can, and as a result of which you can have big storages, like in terms of gigabytes. Okay, so first of all, the CPU will how is the sequence? CPU will first use the registers, then the cache memory, and then the DRAM. Right? We saw that yesterday. What is cache memory? Cache memory is your SRAM. So CPU first will use your SRAM. SRAM khatam ho gaya, to it will use your DRAM. If DRAM is also over, then you have something called as your virtual memory, which we are going to see today. Okay. ROM. Okay. Yesterday we saw ROM. So RAM we have seen. RAM is a volatile memory, and data is not stored permanently in the RAM. Whenever your electricity supply goes away or when your power is gone, your RAM gets refreshed. Okay, the same is not the case with ROM. Okay, so ROM is a read-only memory. So we are talking of primary memories. Okay, we are talking of primary memories. So this is a read-only memory. So if you open up your motherboard, every motherboard is going to have a BIOS ROM like this. Okay, you can see this is a BIOS ROM. This is a motherboard ka screenshot, and this is a BIOS ka chip. Okay, a BIOS ROM chip, we will say. This is a BIOS ROM chip. So it's a BIOS ka ROM chip, please. Here you have your basic input operations. So whenever you switch on your PC first boots from this BIOS. It's a read-only memory. It boots from this BIOS, and only then afterwards does the system gets transferred to the operating system. Okay, the OS comes into picture only after the BIOS has booted. So your BIOS needs to be booted first. Uske baad your OS gets booted first. Okay. Similar photograph you see over here. This is a BIOS chip, and we normally call this as a BIOS battery. Okay. This BIOS battery is used to take care of the timing and all. Okay. So when you switch on your systems, if the system is not connected to the internet, okay, how will it know the time and all? Okay. So that is being taken care of by this battery. So it's a different part as such, but we normally call it as a BIOS battery, because it plays an important role to store some critical information like timing and etc. Fine. So these chips, okay, these BIOS chips are found inside your motherboards. Okay? So your laptops and your PCs, ke andar you will find these BIOS chips. So these are what are called as ROM. Okay, ROM chips in terms of primary memory. Okay, so primary memory ke ROM chips are these that you see. Is it okay? So these are a few photographs that I wanted to show you. Is it okay? So this is SRAM. It's an IC, small IC, which has memory that is very fast, static RAM. This is dynamic RAM that we normally use in terms of DDR3, DDR4, dynamic DRAM. And then you have this BIOS. Okay, so we do not play with this BIOS. We can upgrade the BIOS. Okay, we can obviously upgrade the BIOS. So BIOS upgrade karne ke liye, the BIOS has to be programmable. Right? So here we talk of something called as a programmable ROM kind of a thing. Okay, so programmable ROM or a EEPROM and all we see. Okay, so that is our ROM. The ROM is read-only. That is we are reading. Our main task is to read data from this. Fine. So obviously read karne ke liye, we will have to once write it, right? So that is why you are having the facility to write the data, but we do not write it very often. Right? We just write it once and then we read it, or we write it at some intervals and then we read it. Okay, is this clear, please? Is this okay? Is this okay?
Yes.
Yeah. Yes. Now I wanted to talk specifically about EEPROM. Okay, so apne syllabus mein we are having 8051, right? And we have ARM after that. So when we talk of a MCU, in the MCU we have some memories called as EEPROM, flash, and SRAM. So these three things are very necessary. Okay, what are the three things? One is the SRAM that we talked about. Every MCU has an SRAM. Okay, every MCU has a specific SRAM. Every MCU has an EEPROM or an emulated EEPROM, and every MCU has a flash memory. Okay, so we are just going to touch base on these important things. Now, we saw that we talked of ROMs, right? So ROM are different. We have different kinds of ROM. Okay, you have programmable read-only memory. Okay, where you program the thing by the manufacturer. Then you have erasable PROM. In erasable PROM, the data is erased by means of UV lights. Okay, so I think this thing was pasted down over here in the last lecture. I just corrected that thing. EEPROM can be erased. Okay, erasable PROM. EEPROM can be erased by UV lights. All right, but EEPROM is electrically erasable programmable read-only memory. This EEPROM can be erased electrically. Fine. So when you can erase it electrically, then you do not require this functionality of UV lights and all. Okay, this was the old technology. New technology is you can erase it electrically by means of your ones and zeros or discharges and charges. Fine. So EEPROM can be erased electrically. So it is called as an electrically erasable PROM. Fine. So it allows for programmable data to be stored partially and erased and then reprogrammed once again. That is your EEPROM. Okay. So our concern is to see about EEPROM. Let us just see EEPROM now. All right, I just added this slide. I thought it was important to add a few more things about EEPROM and flash. So here it is. So what is EEPROM? EEPROM is electrically erasable PROM, PROM, program read-only memory. It can be erased by electrical charges. In simple words, EEPROM is a permanent storage similar to a hard drive. Okay. So as we have hard disk, okay, we have a hard disk, and in that we are able to store data that does not get erased. In a similar way, EEPROM is the memory that is used by our microcontrollers to store some memory. Fine. So we have two kinds of EEPROMs over here. One is your simple EEPROM, and then we have something called as a flash. So whenever you want to store some data, okay, some data inside your microcontroller, then you will use something called as an EEPROM. When you want to save your program, fine. So when we write a program, move A comma B, okay, add A comma B, multiply A comma B, all that is called as a program. So program memory, program data or program data is stored inside your flash, and your data memory is stored inside your EEPROM. Okay, let us just check how this happens. So when we have EEPROM, this is an example of an EEPROM. Okay, so this is a 256 kilobit EEPROM, kilobit EEPROM. All right, so this is the model number, and that is what you see over here. Similarly, if you talk of some other EEPROM, if you talk of a microchip EEPROM, this is a 1 kilobit serial EEPROM. Here you have another EEPROM of 10254 bytes, that is 1 kilobyte, right? So 1 kilobyte ka you are having a EEPROM, and this is on the Atmega 328P. So this is the Atmega 328P. It's a microcontroller, and this is the microcontroller that is used inside your Arduinos. Fine. So this is your Arduino over here, and we are using this microcontroller MCU Atmega 328P inside the microcontroller. Fine. So our Arduino also has EEPROM. Our Arduino also has flash. Our Arduino also has RAM. All right. So what is the usefulness of this EEPROM is what we'll see. Okay, we have to differentiate, right? We have to differentiate between RAM, EEPROM, and flash memory. All right. All right. So when I talk of an MCU, we specifically have to talk. I hope you can see my whiteboard over here. We can specifically need to talk about the RAM, that is the SRAM. Please get this in your mind, because it is going to come every time. That is why I think we should spend some time on this. Then we are going to talk about EEPROM. And then we are going to talk about we're going to talk about flash, okay, which I will just talk now in some time. What is stored inside the flash, please, guys? What is stored inside the flash? What is stored inside the flash memory? What is stored inside the flash memory, please?
Data.
Which data? So we are having how many types of data? We have the program data, right? That is the the instruction data, right? The application data, and then we have some other data memory. What is stored inside this flash?
Instruction data.
Yeah, that is your code, right? So we normally call this as the code, our code or our instructions or our programs. Okay, all these things are the same, please. So when you write code in C and then you convert that into assembly and then you store it inside a controller, you're storing it inside the flash memory, please. What is SRAM used for? What is the SRAM used for?
Cache memory.
SRAM. It's a different thing. It's a RAM, right? ये ROM है. ये flash ROM है. What is SRAM used for? RAM.
To access data faster.
Yes, but what do we use it in the MCU? It is obviously faster than flash and EEPROM.
Variables.
Variables, right? We use it for our variable or our, we can say, our real-time data that we can say, or maybe we can call it the data memory also as such. Okay, in simpler words. Now, ये हो गया RAM और ये हो गया ROM. Now, why do we require this extra EEPROM is what we need to see. Fine. So in every MCU, you will find these three things. You will find SRAM and you will find flash. So these are very important. Every MCU needs to have a SRAM. It needs to have a flash. EEPROM, it can have or it cannot have. So we'll have to emulate what is the meaning of an EEPROM. Now, EEPROM is specifically used to store some data permanently. Okay. So we are going to store some data permanently over here. All right. And when we store some data permanently, we can retrieve the data. We can read the data as many times as we want. And we should write the data very, very sparingly. All right. So, आपका main जो program है, that is going to go inside the flash. But there is going to be some use case where you want to store some variable inside a thing which is non-volatile. Okay. If you understand this slide over here, SRAM, EEPROM, and flash, let me go to the example of why do we require a EEPROM. Okay, I will go back to my slides. Right. So why do I require an EEPROM? All right. Now look at this example over here. I hope you understand this. Listen to this carefully and see if you can understand this. Imagine that you are using the Arduino and your LED is off. Okay. At the moment your LED is off, you switch on, you press a button and your LED is switched on. Right. Now imagine that suddenly your power supply of your Arduino goes away. Okay, power supply of an Arduino goes away. What have I done over here? I have made A as on. Maybe A I will tell us LED as on. और यहाँ पर क्या हो गया? A is off हो गया. Now what is my A, guys? मेरा A क्या है? What is my A? It's some variable, I can say, right? It's some variable. The initial value of the variable was on. The next value of the variable is off. Now, when I switch off or when the Arduino loses power supply, what happens? What happens? ये A किधर stored है? Where is this A stored? Where is this changing value of A stored, please?
Inside Arduino.
Yes, inside which memory? Where is the changing value of the variable stored?
SRAM.
SRAM, RAM, very good, superb. Okay, so what happens when the Arduino loses power supply? What happens to the value of this A?
It is deleted.
It is lost. Yeah, it is deleted. Superb. So when you restart your Arduino, what happens? your A is again on, or A is again, मैंने उल्टा लिखा है, I think, sorry. All right, yeah. So here A is off. Here maybe I made A as on, and again A is off when you restart your Arduino. So what has happened? The actual state, okay, the actual state of this A is lost, and we again come back to square one. Why is that? That is because your A, variable A, was stored in the SRAM. We know that SRAM is a volatile memory. Whenever power is switched off, the volatile memory deletes itself and it refreshes and it loses that variable data. All right. Now, what if when you were doing the program, listen carefully, when you were running the program, what if at that point of time you wanted to store this variable ka change? So A became off, say on. What if you wanted to save this state inside some memory which could retrieve it further? Uske liye we use the EEPROM. So EEPROM is used only for this specific purposes. Now, if I am okay with my LED turning off after the Arduino has lost power supply, I'm okay, fine, okay, no issues. I will not use the EEPROM. But I will use the EEPROM if I want the LED state to be retained even after the power is lost. Are you getting what I'm saying? So if I do this case over here, my A is off over here, same thing. Mera A either on ho gaya. All right. And what did I do? Iske saath, I stored this value of A inside my EEPROM. Okay, this is happening when? This is happening when the program is executing. Okay, so real time pe you are storing the variable data inside something called as the EEPROM. All right. Now, when the Arduino loses supply, what is going to happen? I can write the program in such a way that I will instruct the program to read the EEPROM. So when it reads the EEPROM, it finds that, okay, LED state is on. So it will start the LED on restart. Okay, please let me know if you have understood this thing. Please mujhe batao if you have understood this thing. If you understand this thing, you can easily understand what is the difference between SRAM and EEPROM. Do you have any doubts over it? It's very important that you understand these small things here. I mean, these are things that are very logical, and maybe in an interview they will ask you simple things. Kya hai? Why do we require EEPROM? Why do you require SRAM? If you just give them this example, they will be like very impressed with your. Okay, it's some small thing, but you give it in a very simple way, and all these things are what is required when you go for your interviews. Do you understand? Did you just understand what I just said? Do you have any doubts, please? Why don't you ask doubts? If you ask doubts, the other people will also get cleared from their doubts. Any doubt over here, please?
No, sir.
Okay, so why do we require EEPROM? Give me in one word or one sentence. Why do we require EEPROM? Can you just
to retrieve the data even after restarting the Arduino?
Yeah, so from this example, you can see that even after restarting the Arduino, I can get the variable state that was before the same state that was before the power went off or before the restart happened. So that is one use case of EEPROM. There are other uses also where you can store data immediately into the EEPROM and then you can keep on retrieving from over there. All right, so Arduino has a separate 1 kilobyte ka EEPROM. Fine. So please understand these things. These variable states, this variable turning on, variable turning off, all these things are important to understand. So here I didn't use the EEPROM. Here I used the EEPROM. When EEPROM use kiya to I could save this variable data inside my Arduino, inside my EEPROM, and then on restart I could read it. Fine. So ये Arduino का EEPROM read करने के लिए you have separate header files. So you can just search for this header line EEPROM.h, and then inside this you have all the functionality of how to use the EEPROM. So when you write a program of EEPROM, please remind me to use a EEPROM also sometimes. I'll do that for you also. It's a very nice thing. Okay, so you will understand this when you're doing a programming. Why do you actually require EEPROM? You will understand some state like that. Okay. Right. The same thing can be used for a general purpose also, use case also. For example, your AC was switched off, right? So you just imagine this thing. Your AC was switched off. It is switched on now. अभी आपका AC चल रहा है, right? Now imagine that your current goes away, your power goes away. When the power comes back, your AC का controller, it starts from scratch, and from scratch क्या है, आपका AC off था. But what if you save that state inside a EEPROM? Then when the power is recovered, the AC will automatically switch on. So these small things you can see in front of your eyes. Okay, so these things are stored. Okay, these things are stored when you switch over, when you use your EEPROM. A similar thing happens when you use your TV remotes also. For example, if you're watching a channel, okay, थोड़ा पुराने ज़माने का सोचो. When you are watching a channel, imagine that you are watching a channel number 113, okay, or 113 channel आप देख रहे थे. When the power went off, when the power came again, the TV started exactly at 113. If the TV is not starting at 113, means it is not storing that 113 ka value. If it starts at channel 1, that means it is not storing the data inside the EEPROM. From these examples, you should be able to understand that, okay, these things are used real time, real life may also. Fine. Now, the only problem with EEPROM is that it has a finite life. All right. So in Arduino, that is in this Atmega 328P, this is the controller over here. The EEPROM has a 1 lakh write erase cycles. Means you can erase it 1 lakh times. Okay. Not so it's a very approximate kind of a figure. Okay. So it can be more or less than that, but it has a specific life which is very less. Okay. So it has 1 lakh write or erase cycles. So you must not use it always to write data. आप डेटा एक बार लिख दो, फिर उसके बाद you can read data unlimited number of times. So that is our technology of VLSI technology which makes this happen. Okay, please. Fine. So ये EEPROM को आप हमेशा read, you can read it multiple times, unlimited times, but writing that data is for a limited period of time. Right. So this means that you can read from the EEPROM as many times as you want without compromising its life expectancy, but writing and erasing has a specific life cycle of 1 lakh life cycles. Fine. So you must not use the EEPROM for your daily purposes. It should only be used for specific use cases. Fine. So you have the EEPROM. If understood EEPROM, then we come to flash. Okay. Then we come to flash. The flash is the king of our storages. You know, flash drives, and we say this as USB flash drives. So a pen drive is a USB flash drive. This is a USB flash drive. It's a flash drive. It's a flash drive. We have USB flash drive. Fine. So flash drive is the same technology which we use for this flash drives are used inside our controllers also. So we use a flash ROM. Okay. So flash memory is also called as the flash ROM. Fine. So what is stored inside the flash? As we have seen, what is stored inside the flash? We store the actual code, the program or the application code we store. So when we write a program, right, we compile the program, then the compilation creates a binary or the hex file, that is the machine code, and this is stored inside your flash. So if next time someone asks you, Arduino, when you write a controller program, where do you store the program? Your immediate answer should be, we store it inside the flash memory. Fine. So flash memory, you're going to store the entire code directly. All right. EEPROM, you're going to specifically use it for your specific use case. SRAM is used without you knowing it also. Fine. We cannot control the SRAM. So SRAM is used without we knowing it also. SRAM is used to store the variable data and all. Fine. So even flash is a non-volatile memory. So आपने एक बार flash में store कर दिया, even after the power is switched off, the again program will start from scratch. Right? So upon reset, the program will read the instructions from the start and will perform the necessary operations. So basically, your flash is also a type of EEPROM. Okay, it's a main type of EEPROM. The only difference is that iska read-write logic mein there is a difference. Right? EEPROM is we can work at the EEPROM at a byte level. Byte level means आप each byte of data EEPROM का आप change कर सकते हैं. Okay, that is the reason why in the earlier case, if you want to, in the earlier case over here, if you want to store this value of integer, okay, maybe I will say a uint, a small int, uint 8, I will say 8-bit का एक variable है, uint 8 a is equal to on. Okay, so you can store this 8-bit, that is 1 byte data inside the EEPROM also. Fine. So EEPROM can be accessed byte-wise. So each byte of the EEPROM you can access. So if your EEPROM has 1024 bytes, that means अगर समझो ये आपका EEPROM है, it has 1024 bytes. Maybe it has some. Maybe I will say this is the 0th byte. This is the first byte, the second byte, the third byte, the fourth byte, and so on up to 1024, 1023 byte. Then you have 1022 byte. Okay, so what is the beauty of EEPROM is that you can access each and every byte and you can store some variable over here. समझो कि आपने ये डेटा, ये वेरिएबल था a, this variable you stored maybe in the 512th byte. All right, so what is the beauty of this EEPROM is that आपने ये वेरिएबल को आपने 512th byte पे स्टोर, byte पे स्टोर कर दिया, then you can read also from the 512th byte. आपने इधर स्टोर कर दिया तो यहाँ पर पॉइंटर डाल के you can read this data also. Fine, that is the beauty of an EEPROM. But we cannot use this EEPROM for our main code memory, because code memory has to be erased a lot of times. So we do not use the EEPROM. We use something called as the flash memory. Okay, because flash can be erased at a block level. So पूरा block को, so if you have bytes like this, then EEPROM can be accessed. Then flash can be erased at the entire block level. Fine. So flash is used when the need arises to erase large chunks of data, not on an individual byte basis, but on an entire block level. Okay. So this is the king of our memory, right? Flash memory. All right. Your SSDs are also called as flash memories. Your pen drives are flash memories. Memory cards are flash memories. Flash memory is the place where we store our programs. Okay, so if you see this ESP32, so it's a Wi-Fi chip. Okay, you will find that ये आपका Wi-Fi chip है, ESP32, और यही chip में you are having, you can see this block is an external flash for the ESP. तो ये ESP का, this is the chip of the ESP32, and this over here is a external flash. You can see how big it is. It is a 4 MB ka flash. Anyone remembers what is the flash of our Arduino? Anyone remembers what is the flash of the Arduino? कितना bytes है?
2 KB.
नहीं, वो SRAM है. SRAM is 2 KB. What is the flash of the Arduino? You are close. 2 के साथ एक और
32 KB.
32 KB. Okay, 32 KB, 32 kilobytes. Very good. 32 kilobytes is the flash of Arduino. इसका SRAM is 2 kilobytes. Okay, SRAM. RAM. वो RAM is always costlier. ठीक है, तो SRAM हमेशा कम रहेगा flash से. Any doubts? ESP में you have, just imagine this, Arduino is 32 KB and your ESP is 4 megabytes. It is 4,000 kilobytes. Okay, so nowadays we use the ESP instead of the Arduino. I specifically use the ESP instead of the Arduino for majority of the purposes because of this thing. Right? There are obviously different use cases, but this is one of them. Just mute yourselves. ठीक है. All right. So when you talk of an hardware architecture, hardware में क्या रहता है? Program memory and data memory दोनों अलग रहता है. Program memory we store inside the flash. Data memory we store inside the SRAM. And if you want to store some data memory inside a non-volatile, then you will use a EEPROM. This slide makes it very clear. Okay. A program जो है आपका वो program data is stored inside your flash, no problem. Data memory at runtime when the program is actually running, it is stored inside the SRAM. But okay, it's a but please. If you want to store any variable that keeps on changing into the EEPROM, then you must. If you want to store any variable that keeps on changing, then you can store it inside the EEPROM. Fine. So please understand this. तो ये दोनों non-volatile है, flash and EEPROM. What is the meaning of non-volatile now? If you have understood everything, what is the meaning of non-volatile and volatile? What is the meaning of non-volatile and volatile? Simple way में, if you understood the entire picture. बोलो in terms of the logic, what is volatile, non-volatile?
Temporary and permanent.
Yeah, temporary and permanent. So it is based on the power going off. Okay, so if the power is lost, okay, or the supply is gone, if the data goes away with that, then it's volatile. If the data remains, it's non-volatile. All right. Okay. Can someone from the DSC students, please? Can someone please inform Frida ma'am that I will take 10 more minutes? You can just message her or just call her up. Can someone do that? Is there a CR in the DSC students, for DSC students? Do we have a CR, please? Can someone please inform Frida ma'am that I will be taking 10 more minutes so that she is informed about.
Sir.
Yeah. Okay, and what I was saying, same thing, EEPROM में you can individually target your bytes. Okay, individual ये सब byte level पे काम कर सकते हैं EEPROM में. In the flash memory, you talk in terms of the entire row. Okay, we call it as block based. So ये पूरा block को you can access, and over here you can access the individual bytes. Okay, this was about extra about flash and okay, so this is about an example. All right, so if I go to a STM32L476, so it's an ARM controller board. So if I go to this link over here, okay, if I go to this link over here, you can go to this link please, and you can just check out ये link पे. If you go over there, ये इसका screenshot मैंने लिया है. Okay, so this is what this is an ARM controller, ARM Cortex M4 controller. You can see how they give in the data sheet. So memories may will say, okay, it has 1 MB of flash and it has 128 kilobyte of SRAM. Do you see any EEPROM over here? Do you see any EEPROM over here? Do you see any EEPROM over here?
No.
No. तो क्या होएगा? तो what can happen? क्या कर सकते हैं हम लोग फिर? If you are not able to see an EEPROM over here, what do you think I can do if I want to have if I have the same use case as the LED? It has 1 MB of flash and it has 1 MB and 120 kilobytes of SRAM. What do you think can happen if I want to use if I want to have a functionality of an EEPROM? Any wild guesses? What is EEPROM? EEPROM किसका भाई है?
Flash.
Flash. Okay, so very good, super. So EEPROM and flash are very much interlinked to each other. Flash is a type of EEPROM. We can say EEPROM is a type of flash. First EEPROM came, उसके बाद flash came. Okay, so we can say flash is a type of EEPROM. So what happens? You know what we do in this? We have done this for some of our projects. We individually emulate. So it is called as an emulation. We emulate the working. Emulate मतलब क्या है? मतलब it is not there existing at the moment, but we are trying to create an environment of an EEPROM inside the flash. Okay, so they're trying to emulate the working of an EEPROM inside the flash itself. Okay? So there are techniques of doing this. Okay. We checked this yesterday. We will just talk about cache. Fine. So cache is the data that is nearest to the CPU. Fine. So CPU ke andar you have registers L1 cache, L2 cache, and L3 cache. Then you have main memory, that is the RAM, DRAM. Okay. This cache memory is what? SRAM, closest to the CPU. Then you have DRAM. Then you have the hard drives. And then you have the optical, that is the CD drive and all these things. Now, we had talked about cache, right? What is cache used for? Why do I require cache, please? Anyone? Why do I require cache memory? Why do I require cache memory? So I told you this is within the CPU, right? And this is the actual DRAM. ये CPU के अंदर है और ये क्या है? ये सब SRAMs है, right? Yeah, why do I require cache memory?
To load the programs faster.
Very good, super. To load the programs faster. Okay, so if you're using a laptop or a PC, to load programs faster, we can use these cache memories. Okay, so bigger the cache memories, bigger is the amount of the program which can be stored inside your systems. Fine. So if you must have seen this, right? When you start the program and you again restart it, you're going to do it in the cache memory itself. Fine. So CPU first goes and checks the cache. Our cache में data नहीं है, then it will go and check it will go via the memory into the hard disk and get the data into the memory. अगर data already exists कर रहा है L1, L2, L3 में, so it will take it from there and so it is fast. If it is not there, it will check the RAM. इधर भी नहीं है, then it will go to the hard disk. So the sequence is like this. Okay, CPU first checks the cache. Cache में अगर वो required data है, it will take it from there. If it is not there, it will go to the RAM. यहाँ पर भी नहीं है तो then it will go to the main hard disk to get the data. Right? That is how the sequence is. Now, so this is an extra slide, please. So cache is divided into three parts: L1, L2, L3. L1 is the costliest. L2 is cheaper than that. So L1 costlier than L2, costlier than L3. Okay, and size-wise, this is going to be bigger in size than L2 than bigger in size than L1. So all these are SRAMs, please. Fine. So L1 cache is the closest to the CPU. So this cache is there inside this CPU ka block itself. So you must have seen the CPU, right? So this is a Intel ka, maybe Intel or AMD CPU. So inside the CPU you have the cache. L1 cache is inside this, L2 bhi iske andar hi, okay? Even if it's told as an external cache, but it is there inside the CPU ka block itself. Inside this chip itself, you have the L1, L2, L3 cache. So L1 cache is closest to the processor. Uske baad you have L2 cache. So if the CPU does not find data in L1, then it looks at L2. L2 bhi nahi ho, it will looks at L3. If it is not there in L1, L2, L3, then it will go to the RAM. Agar RAM mein bhi data nahi hai, then it goes to the hard disk. So if you are taking a data from the hard disk, it takes it takes more time than it would take from L1, L2, L3 caches. Okay, so if you look at a Core i5 as such, if I say, they don't give you specifications of L1, L2, L3 cache. If you go to the data sheet or if you go to the web page of an i5, you will find that it just says 12 MB of smart cache. इतना ही बोलता है. If you go to a old one, okay, Intel Pentium 4 ka thing, you will find that it gives you a 512 KB of L2 cache, it says. Fine. So all these things are used in our main big systems, okay? And this was what we had seen last. Okay. All right. Now I'll just take 5 more minutes of your time. I'll just brief on virtual memory, not go much into virtual memory, just brief on virtual memory and then we can stop. Have you informed Frida ma'am? Someone? I think someone had said a yes, right?
Yes.
Okay, ठीक है. Just briefly touch on memory. Okay, this is just the levels of memories, please. Just share. All right, so this is the levels of memory. So we know register memory, CPU cache memory, main memory, that is RAM, secondary memory, and then other memories in the cloud, maybe on a server, etc. Okay, so this is how the capacity goes. So this is it goes like this. Capacity goes like this, and cost goes up like this. Right? So you put a inverse it totally. Now, instead of this, in addition to this, for example, if I want to emulate, okay, if I want to emulate the working, now you know the meaning of emulate, right? If I want to emulate the working of a RAM, if I want to emulate the working of a RAM or a SRAM in a hard disk, okay, so you must have sometimes imagined, right? You must have thought, right? Okay, I have a 500 GB ka hard disk. You must have thought about it, right? I have a 500 GB ka hard disk. Why can't I use that as a RAM? Have you ever thought this? Have you ever thought about this? Yeah. So we have 4 GB of RAM, we have 8 GB of RAM, okay, but we have 500 GB of hard disk, we have 1 terabyte of hard disk, okay. Now why can't I use?
It is too much.
Yes. 1 second. I will just start a system monitor. You will be able to understand this. All right. So you must have sometimes thought that why can't I use my hard disk also to make it use as a as a real DRAM or a SRAM kind of a thing. So that is possible, but not in a actual sense, but in a emulated sense. Okay. So that is why we call it as a virtual memory. Fine. So there's a concept called as a virtual memory. So virtual memory is what? It's an alternate set of addresses of memory locations. Fine. So these memory locations are existing in the hard disk itself. So what we do is that we make the hard disk work as a RAM. Okay. So RAM ke jaise we make the hard disk work, but not in a complete sense. Okay. It is not in a complete sense. You cannot make it actually work as a RAM, but we try to emulate the working of a RAM inside the hard disk. Fine. So we can store a few programs and all inside this virtual addresses that are there inside the hard disk, and that then can be converted into real memory addresses. Fine. So it's a very complex. So virtual memory is a very, very complex system which works and which helps us to actually do more from a limited amount of RAM also. For example, if you have only 2 or 4 GB of RAM, if you have a big virtual memory ka space, then maybe your program will run a bit better than if you didn't have any virtual memory ka space. So what is the main meaning over here is that we are trying to use the hard disk somehow or the other like a RAM. Okay, so this concept was developed quite earlier, and now we are using it as kind of a virtual memory or a swap memory. Okay, what is the objective of using this? Okay, when a computer is executing many programs at the same time, virtual memory makes the computer share memory quite efficiently. Fine. So if I just show this to you, show to you the system monitor from my Linux system. Okay, you will find, you can see this is, I hope you can see this screen, right? Yeah. So if you see the system monitor, so ये है मेरा CPU का history, right? So my CPU is running like this. So I have 4 cores in my CPU. So CPU 1, CPU 2, CPU 3, CPU 4. Okay, 4 cores running like this. If you have Windows, you can check this in Windows also. मेरा network history है ये. So this is my data, how my data is coming. If you see over here memory, okay, look at the memory part over here. Look at the memory part. I have memory and swap memory ka history. Now memory means my actual DRAM. Okay, so I have 8 GB of actual DRAM. Okay, I have 8 GB of actual DRAM, and wo 8 GB of actual DRAM mein I am using 5.3 GB of that 8 GB, okay, or 7.71 GB, 7.7 GB. So ये है मेरा actual DRAM. Now there is something called as a swap memory also. Okay, this swap memory is 9 GB. Okay, so when I was installing this version of Linux, I gave 10 GB. Okay, I gave 10 GB of my hard disk space as something called as a swap memory. Fine. So if I have a 200 GB ka hard disk, उसमें से मैंने 10 GB I give it as a swap memory. So what does a swap memory do is that this swap memory, it is the actual hard disk memory, but when your main memory, okay, so imagine that this becomes 98%, okay, when it becomes very high, what happens is that we will offload some of this task onto this swap memory. Okay, it may not be so efficient as the DRAM, but it is better than not having any kind of a external virtual memory. So this swap memory is called as a virtual memory. So virtual memory में क्या होता है? You are actually using your hard disk का space. You are trying to emulate it to work in terms of a RAM, but you are not trying to make it exactly as a RAM. Fine. So if for example this memory का usage is higher, then the swap usage अभी तो बहुत कम है. It is only 0.5%. Okay, there is almost negligible use now. But when my system becomes power hungry, resource hungry, this thing will increase, and I should be able to get a better performance if I didn't have any kind of a swap memory. Fine. So in simple words, this is a virtual memory kind of a concept where I am using the hard disk to work in terms of a RAM memory. Fine. So if you open up your Windows maybe if you go to your Windows Explorer, File Explorer, यहाँ पर जाके आप virtual memory को search कीजिए. You will find that you will have some amount of virtual memory which is used. Okay. So अगर virtual memory use कर रहा है तो this memory cannot be used for anything else. Okay. ये hard disk का portion cannot be used for anything else. Let me just check for some. Okay, we'll just stop over here. I think this should be. This should be fine for today. Maybe I will have less questions of this virtual memory section. We'll do it some other time. Okay, I need to talk to you about this thing called as a memory MMU. Okay, MMU is important. So memory management unit with segmentation is important. Okay, so we'll talk on this maybe some other time. So this will not come as a part of your IA exam. Okay, MMU and segmentation. Uske pehle I may just ask you what is the meaning of a virtual memory and all. Fine, but we'll not go into MMU and segmentation. It's a very small part. Okay. But when you go into it, it is quite in detail. Okay. Fine. So we'll stop over here for today. I'll take your attendance, and then we can leave. Fine. Please check into the application, all of you. 51 of you have checked in today. Good. Sakshi, Kajal.
Present, sir.
Present, sir.
Okay, Abhishek, Adarsh, Aditya.
Present, sir.
Yeah, I want everyone to do one thing, please. आपके academy में please rename your first name with your roll number. Okay, for example, if there is Adarsh. Okay, Adarsh, what is your roll number?
So 02.
02. Okay, so please write 02 underscore Adarsh as your first name. Fine, because I need to sort this, right? मुझे अभी attendance निकालना है, default list बनाना है, so I will not be able to then sort it, please, because there is no roll numbers over here. So please, okay, everyone in academy, okay, everyone in academy, please change your academy में, okay, your name to your roll number underscore your name as your first name or whatever is that column. Fine, please, everyone, please, all of you. If I am not able to do that, if you are not able to do that, then it is difficult for me to make the attendance sheet default list. All right. Yeah. Anuj.
Present, sir.
Bhagesh, Darshan.
Present, sir.
Present, sir.
Okay, I'm just randomly calling now. Nathaniel, Nidhi. Nathaniel is there. Nidhi. Omkar, Pooja.
Present, sir.
Pooja.
Present, sir. Present, sir.
Pratham, Pranjali.
Present, sir.
Present, sir.
Ravina, Rishi,
Present, sir.
Ravina, Sarika, Satyam,
Present, sir. Satyam. Hello.
yeah, Shivraj, Shriya,
Present, sir.
Present, sir.
Please check out. Do not tell me afterwards I have not marked you. Please check if I have marked you present or not. All right. Okay. Before I go, one more thing. I have sent to Ravina and to Disha. Who's the third CR? I forgot. Pratham. Who's the third CR?
Sir,
It's Gaurish.
Goresh. Okay. Fine. So I will give it to you all also. So I have sent to your 2 CRs, 3 CRs, Ravina, Disha, and Goresh. I will send to Goresh now. The link for the mini project groups. Okay. So before you fill the main sheet, there is a sheet called as email IDs. So everyone should please fill in their DBIT email IDs over there. Fine. So please fill in your DBIT, your name and your DBIT email ID over there. I'll just share that with you once. Fine. Only after that will I give you access to make the main sheet. Okay. So all of you, I'll give the link. You can maybe I'll give the link here itself in the chat box now itself. Please wait. All right. So this is the sheet where you have to fill in your roll numbers, group number names, and your group leaders. Fine. You will not have access to this now. What you must do is that you must go to this DBIT email and please put your DBIT IDs. Only DBIT IDs. No Gmail, nothing. Only DBIT IDs. Okay. I have kept this link open. I'll give this link. I'll give you the link. Goresh, right? GOU. Goresh Sankhe. Is it correct?
yes, sir.
Yes. Fine. So please use your DBIT IDs only. Okay. Please use your DBIT IDs and you have to fill it. Okay. For the moment, I'll give you the link. I need to open up the link, right?
Sir, even I haven't received. I just checked. Can you share it again?
No, you
What's
must
this, sir?
have received. It should come in your DBIT mail. Just
Okay.
check.
I'll just check again.
Okay, please log in with your DBIT email addresses only because I'm giving that access. So I will give it access for anyone. All right, please fill in your, first of all, please fill in your email addresses. Then I will give you then I will close this access and I will give access to only the DBIT email addresses. So in that way, we'll get all your email addresses also, only dbit.in addresses. If you don't have it, please go and check it in the server room. Okay. All right. Thank you, everyone. We'll meet next week. Thank you. We will tomorrow for the mini project at 9 a.m. Fine. So I tell it now itself. Tomorrow 9 a.m. to 11 a.m. we'll have mini projects. Mini project ka Arduino. If you have Arduino, if you have got your Arduino, well and good. If you have not, please go and buy it. Right. Thank you. I'll close the meeting.
Thank you.